Okay, we have retained another interesting integral from the UNSW Integration Bee 2024. This was round 2, problem 14. We have the integral of x tan x plus 1 all squared dx. Okay, now this was a good one. This was actually a pretty interesting variation on something we've done before. Now, to start with, I don't really know how to deal with this the way we have this right here. I can't really, if I do a u substitution right now, I don't really think that's going to work that way. But I think what could help is if I just actually multiply this out, just expand it, square it. So we're going to have the first term is going to become x squared tan squared x. The middle terms are going to produce something like 2x tan x, and then for the last, and then squaring the last term, we're just going to get a plus 1 on the end. And now at this point, we could probably break it into 3 separate integrals, but that's not looking that promising. But there are some things we could do here. Now, first of all, we've got an identity for tan squared x. I can actually rewrite this as secant squared x minus 1. And then let's just rewrite this again. I'll distribute in this x squared here. So when I do that, first we're going to have x squared secant squared x. Then distributing x squared to minus 1, we'll have minus x squared. I'm going to put that at the end. We'll have a minus x squared over here. All this plus 1, and then we'll just bring down this 2x tan x. And now the reason I put it in that order is just noticing, looking at x squared, if we take the derivative of x squared, it's just 2x, and we have that right there. And then also looking at tan x over here, well, if I take the derivative of tan x, I've got the derivative here, just secant squared x. And as it turns out, the reason this one's a little different is because what we have over here, everything over here is just the product rule. But then we've got some extra terms over here to the right, but this is just power rule. So this isn't going to be a big deal over here, and we can use the product rule over here. So now just looking at the product rule over here, what I want to do is we'll just take this. If I integrate on both sides here, then what we want is we want this right here to be exactly like our integral. And then here we're integrating a derivative. So the solution of this is just going to be fg. So we just need to figure out what our f and g is. Well, coming back here, we've already determined we have all the right derivatives everywhere. What I can do is, so we said secant squared x is derivative of tan x. I can call this f prime. Then that means tan x is going to be our f. And then coming over here, we'll say this x squared is g. And so the derivative of g prime, that's going to be 2x over here. So therefore we have our f and g, and we can use that as part of our solution right here and here. So let's put that part down. We're going to have this is going to be x squared tan x. And now all we need to do is just deal with the power rule on this, and then we can finish it off. Okay, now that we have everything brought over from the previous board, we have this thing that we just found from the reverse product rule. So let me bring this down here. We'll have x squared tan x. And then here we just need power rule. Integral of 1 just gives me x. Integral here, we're going to have minus x cubed over 3. Add a plus c on there, and that's it. Okay, there you have it. Good one from UNSW 2024. Thanks everyone for watching. Have a good day.